The clear next step for me, though, is to go back to what we did today and extend that into the T-chart and pull it apart tomorrow. So I think tomorrow what I'll do is I'll focus solely on learner B and not even worry about learner A's strategy just yet, since there was so much discussion around learner B today.
Things that I think was really clear from this lesson was that the kids were really engaged in it. And to me, it was the perfect example of the difference between a re-engagement lesson and a reteaching. Because what you did is with the re-engagement lesson, the focus is on the kids. There's where the primary source of action is. It's the kids. With the reteaching, it seems to me the primary source of action is the teacher going over something again. But this thing, the kids just kept digging. They thought they'd had it figured out, but they kept going and going, and they realized that, oh, I didn't quite have this, and they really got into it. So I think they're going to be excited to take this on again, keep going with it.
So it speaks to the real power of re-engagement. It's student-focused.
One of the things that came up today that I heard a lot, especially in the reflection piece and looking through the cards as well, was this notion that, well, I see how that person's doing it, but I'm right, and this is the how. So that's philosophically a direction that I want to go with my class, is to kind of push that envelope a little bit and really to see that there are multiple correct ways to see what's happening in this pattern and in many different patterns, and that actually I'm just thinking about Kelsey and Kylie and how they were feeling that way about their own strategies, that they were both right, but getting them to both come to the conclusion that they are both right and they're equivalent, I guess, just kind of a global perspective.
So a starting point for that might be what you had said before about going ahead and finishing the in and the out table for both ways of seeing it, then graphing it and seeing that the in and the out table, the X and the Y are the same in both cases, the rule is the same in both cases. Something that jumped out at me is what you referred to as well, is their seeming inability to let go of how they were thinking about it and really look at somebody else's work. Because when that group that I was talking to, and I saw them referring to 11 groups of 3 plus the 4, they never had gone back and actually counted to see that there were really only 10 initially, because when they were first presenting, they referred constantly to 11 groups of 3. It didn't seem to bother them when they did realize that there was only 10 groups of 3, and they still didn't put that together. So I'd say probably a lot more work with exploring different ways of looking at it, and I'm going to go back to saying I think they need to talk about it. I think they need to talk to somebody about how they're seeing and see, if they can prove it. Maybe justifying and proving how they're seeing it might be a way to get into
that group in particular. One of the things that came up that sort of surprised me around the mathematics today was this reason why your graphing took longer, or your member talk took longer, is how they thought that the correct way to represent the rule, is it x3 minus 3, is it 3x? I thought that was kind of a really interesting conversation. It's surprised, where did that come from? But looking at it, there was a discussion at I think it was Eric, he was talking about, well, is it X groups of 3 or is it 3 groups of X? So is it X 3 times or 3X times? And then I saw that again with the 11 and the 3. Is it 11 3 times or is it 3 11 times? I think there's a little muddiness around that concept, and I think that they understand that the order in which you multiply things doesn't matter, but it does matter when it's tied to some real situation. And a lot of mathematics we do here is tied to a real situation, and that matters to them. Sure. Is it 3 11 times or 11 3 times? Because one represents the reality of the patterns we were seeing, and one doesn't. So I think that's something that kind of
surprised me. It's a key point.
Yesterday when I did a number talk on graphing a line, it came up. Are we talking about 3 groups of X or X groups of 3? That conversation started yesterday. And there was a lot of confusion around, well, what is the situation that we're describing? And so it boiled down to the learners looking at, for each iteration on that line that we were graphing, how far over on X were we going and how high on Y were we going. So the idea of rise over run, the slope. So without talking slope, they were kind of puzzling about it and wondering if that had a relationship to how they should write the rule. So I thought that was a really good direction for them to be heading, and I agree with you that there is still some fuzziness around how should I represent my rule. I was really fascinated by the whole notion of pattern zero. There were a few learners that were bringing pattern zero up, and then David said, well, you can't go any further once you get to pattern zero. And in a way, he's right, because he's thinking about the buttons, and we're not going to have negative buttons. But when we start talking about functions and we're graphing those functions, we definitely go into negative. We go into integers. So I don't know. I kind of see that as another place to go with this. And nice thing is that I've got a full year's worth of material out of just.
I would say so.
Last couple of days of lessons,
It was extremely well done, and we thank you so much for letting us come into your classroom and view your work with your wonderful students.
Thank you.